So, in this video, we are going to discuss supervised versus unsupervised learning. In machine or in statistical learning, problems usually fall into two groups. We have supervised learning or supervised problems and unsupervised problems or unsupervised learning, right? Unsupervised learning. Cool. So let's discuss these. For supervised learning, each observation of the predictor measurements xi, right? I equal to 1 up to, let's say we are observing n, we have n observations. There's an associated response. So we have an associated response yi. What this basically means in simple English is, let's say our y that let's say we have observations of people, right? So for each person of the 9, for each person of the 9 people, we have what? We have associated, let's say, income. We have associated income, right? And these x's could be anything. They could be each person's age, education, each person's school. So which means for each person, we have their age, their education and school, and associated with those, we have the person's income. So that is supervised learning. We know how the age, education, school, not like we know how, but for each person, we have their income and their characteristics here, the age, education. And so let's just say this is a table. A table, we have age, education. So this is a table in our data set. Let's just say it's in Excel or something for a company, right? And so which means we can put their age, they're 25, their education, yeah, let's say they have a bachelor's. The person has a bachelor's degree. The school they went to is Wits University, and their income, let's just say they're earning 30,000 Rand a month, right? Earning 30,000 Rand a month. And for the next person, we have the age, the education level, the school, and their income, which is very important because for each, the x's are ending here, right? And for each person, we have their x's, these x details here, we have their x's, and importantly, we have their y, which is their income for each and every person, right? So what we wish to do in supervised learning, we wish to fit a model that relates the response, which is in our case the income, the response. We wish to fit a model that relates the response to the predictors, to these predictors. Let me write predictors, with the aim of accurately predicting the response for future people. Let's say future observations or future people. That is one case, right? Our case is we want to predict y or income. In our case here is income for future observations. What it means is for people who then walk into our company, we'll ask them, what is your age? We get the age. What is your education? We get their education. What is their school? We get their school, right? But for that new person, we do not know what their income is. So using the data that we know in supervised learning, using the data where we know everything, we want to fit a model that will allow us to predict this income level for a new person or a new observation or future observation. So that is the predict modeling. Or for interpretability, right? For interpretability, we want to fit a model that will allow us to know the association between the x's, between any x and the income level or the y. Does it make sense? So we want a better understanding of the relationship between predictors and the response. So there are two ways. Maybe we want to model for prediction. We want to know y for future observations, or for interpretability, where we want to know the relationship between y and each individual x, each x. Does it make sense? I hope it does. So examples of supervised learning models, like techniques we can do linear regression. Linear regression is definitely supervised learning, because we are regressing the y or the income on these x's that we already have. 2, we haven't discussed some of these, but logistic regression is another supervised learning method. We're going to see a chapter dedicated to logistic regression and yeah. GAMs, they are supervised learning algorithms. Boosting, supervised learning, and then SVM, support vector machines, they also fall under supervised learning algorithms. In contrast, unsupervised learning describes something that is a bit more complicated and challenging, in which for every observation xi, so for every observation xi, let's say we have n people, right? Just like we did, we do not have an associated yi. We don't have an associated yi. So for these people, we might have their age, education, school, but we do not have their income level. We just have these x's, the characteristics or demographics of these people, right? It is not possible to fit linear regression in using unsupervised learning data, because there is no variable to predict, or no variable in statistical learning terms. We would say there is no variable to supervise our prediction. We don't know whether we're doing it right or not, because there's no income to say yes, we've done it right or we haven't done it right. There's nothing to predict there, right? So we cannot use unsupervised, we cannot use linear regression in unsupervised learning. It is unsupervised because we lack a response variable that can supervise our analysis, right? So this, where can we use it, you might be asking? Because it seems useless because there's nothing to predict. Actually, it is not. We use this in cluster analysis. Some people just call it clustering. In clustering, this clustering is used to understand relationships between our observations. So between our people, let's say we have person number 1, person number 2, person number 3. We want to understand the relationship among these people, or let's say our observations. So we want to know the relationships among these people, and we do that by clustering them. Let's give an example. For example, let's say we are doing a market segmentation study. If you're doing a market segmentation study, a company might be saying, okay, we have observed multiple characteristics or variables for potential customers. Let's say potential customers, we observed their age, education, and school. Then for another person, we observed their age, education, and school. Another person, age, education, and school in our study or survey, whatever it is, right? Then after doing that, we might believe that customers fall into different groups. So let's say let's add some variables that are important here. Let's say family, we observe their income. We observe their income as well, and we observe, let's say, their shopping habits. Their shopping. We ask them how often they go grocery shopping, and they say I go twice a week, 3 times a week, whatever it is, right? So here we might then say, we might believe that in this data that we gathered when we did this survey, we might believe that customers fall into different groups. For example, we might believe that there are some people who are big spenders, and we have some people who are low spenders. Some people who are low spenders. So if in our data, after getting this information, and we had a column that was now saying group, and for each person would say, oh yeah, we've collected this, and you are a big spender, you are a low spender, big spender. That would be good, because we would use this group to do supervised learning. You know what I mean? We would use this as the target variable. or as the response variable, big spender, whatever. But then when we are at the shopping mall gathering this data, we don't know who's a big spender or who's not a big spender. We don't know that. So we want to cluster them into the big spenders need to go to the big spender based on this data that we've collected, and the low spenders should be with the low spenders based on that same data, right? So we use unsupervised learning because we do not have a target variable that we want to predict. We just want the algorithm to look at these X's that we gathered and then try to group people based on that. So it's going to say, people of this age, education, school, income level, shopping habits, I think they belong to the big spenders group, or they belong to the same group, and we can tag that group as big spenders based on what we've observed. And then it will put also other people to be like, I've looked at their age, education, shopping habits, blah 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 blah, and I think these guys belong to the same group. And when we look at the group, we can say, that is the low spenders group. Yeah, we didn't target any variable. We just grouped people together, or we clustered them. We grouped or we clustered them, and that happens in unsupervised learning. I hope you now see the difference between supervised learning and unsupervised learning. In this course, we are going to mostly focus on, I think we are going to only focus on supervised learning because there are so many use cases of supervised learning. In another course, when we're doing, especially like deep learning and stuff like that, we will look at some unsupervised learning techniques. So in this course, don't worry, we are not going to get into unsupervised learning. We are going to focus on unsupervised learning algorithms. In the next video, we are going to, let me look at my notes. We are going to see the difference between regression and classification problems, and those fall under, they will be falling under supervised learning. So stay tuned for that video.